Number 21, letter A. Find the ratio of the electrostatic to gravitational force between two electrons. All right, so let's start with what they're asking. They want a ratio between the electrostatic force, so F sub E, to that of the gravitational force, F sub G. Now the electrostatic force is given in the equation over on the right-hand side, right? It says that it's the electrostatic constant, K, multiplied by the absolute value of the products between the two charges, all right, Q1 times Q2, and then divide that by the distance between them squared. All right, and that's now going to be then divided by, so that's the electrostatic force. Now what's the gravitational force? So that's a throwback, right? That's going to be the gravitational constant G multiplied by the mass of one times the mass of the other, all divided by now their distance between them squared. All right, now this is cool, but this looks like a nice complex fraction, so why don't we just reorganize this a little bit to take the numerator fraction and multiply it by the reciprocal of the denominator, okay? So basically what we're going to have now is K times Q1 times Q2 divided by then R squared, multiplied now by the reciprocal of this, right? So it's going to be R squared divided by the gravitational constant G times M1 times M2, all right? Now notice what happens here. The R's cancel. Right? And now we're simply left with this divided by this. So it's basically the electric stuff, right? So it's going to be K, which is, I'll just write it on out now, 8.99 times 10 to the 9th, multiplied by the two charges. Now this you got to know, the charge of an electron is going to be negative 1.6 times 10 to the minus 19, but we just need the magnitude, so just plug in the positive value. 1.6 times 10 to the minus 19. We're also taking the absolute value of it, so it really doesn't matter. Times m 1.6 times 10 to the minus 19. There's two of them. And then divide that now by the gravitational stuff. All right, so the gravitational constant is 6.67 times 10 to the minus 11. Then multiply it by now the masses. So what's the mass of an electron? This you got to memorize. It's 9.11 times 10 to the minus 31 kilograms. And then the second mass is also an electron, so 9.11 times 10 to the minus 31. All right, and let's just calculate now. So 8.99 times 10 to the 9th times then 1.6 times 10 to the minus 19th squared, essentially. Then divide that by parentheses. 6.67 times 10 to the minus 11, multiplied then by 9.11 times 10 to the minus 31, and that's essentially squared. And what do we get? We get a value here, the ratio now, and I'm just going to write it over here, is going to be 4.16 or so times 10 to the 42nd. Okay, that's the ratio. And that's really to 1, meaning that for electrons, the electrostatic force is, a magnitude 10 to the 42nd. That's pretty large, to 1, when compared to the gravitational force. So as you can see, the electrostatic force is, 42 magnitudes stronger, right, than the gravitational force here. Now for letter B, what is this ratio for two protons? So I'm not going to derive the whole thing again because it's going to work down to this. The only difference now will be in terms of the Q's, right? The Q's are the same. That's not the difference. The charge of a proton is the same as the electron. It's just positive. So those values stay the same, okay? But the mass now is going to be different. So instead of the mass of an electron, the mass of a proton is now 1.67 times 10 to the minus 27. So now you got to take them and multiply them together instead of the 9 times 10 to the 31. So why don't we redo that calculation again? So 8.99 times 10 to the 9th times then 1.6 times 10 to the minus 19th, squared essentially, right? And then divide that now by parentheses 6.67 times 10 to the minus 11th, multiplied then by 1.67 times 10 to the minus 27 squared. And what do we get? So now for the proton, all right, I'm just going to write it in red. It's going to be 1.24 or so times 10 to the 36th times larger, okay? So it's less, right? And then letter C says, well, why? Letter C says, why is this the case? I think we know, right? I mean, the masses are different. So there you go. All right, guys, thanks for tuning in. Appreciate it very much. Please remember to subscribe, and we'll see you soon. Take care.